Good morning, everyone. Hello. So I hope everyone has had their coffee. And I also would like to know, show of hands, how many people came to the talk yesterday, the one about cognitive services? So it looks like pretty much a good portion of the room. And that makes me really excited because this last night at 2 a.m., I was inspired. So that is what the door on the room says, and this is what we're going to be talking about. So it doesn't really do us any good to walk through a machine learning example towards the end in Azure Notebooks if you guys don't already have a background in machine learning or deep learning. So what this is going to be, the way that it's going to be structured is for the first 15, 20 minutes, we're going to talk about what machine learning is and what it isn't, what deep learning is and that it's a subset of machine learning that you would use at a very specific time, and what the strengths and weaknesses are of each. And then once we have kind of a firmer grounding in that, we're going to be just talking about Jupyter Notebooks, which is an open source project that Azure Notebooks implements in a free manner to make them freely shareable, and give you a ton of resources if you want to learn additional things. So hopefully that'll be useful to you. I got really excited when I was making it. So, and as always, if you have any questions throughout the talk, feel free to raise your hand and we can have a discussion. So who am I? Sorry if this is redundant. I am Paige Bailey. I work for Microsoft. I do things with computers. I have about 10 years of experience with Python and 4 with R. Prior to joining Microsoft this August, I worked in the energy industry as a data scientist for about 4.5 years. So I started doing geophysical plugin development, and then when they realized that it was more data science, they decided to call me a data scientist. So primary focus was building out predictive models, first locally, so in R, kind of on smaller data sets, and then in a Hadoop environment, so using tools like Spark, if you guys have heard about that. So it was a lot of fun. Microsoft is more fun. Very delighted to be here and very excited to be working on the tools that I was just an end user of. So as I mentioned before, there are really 2 options. You can either build your own model, you can roll your own, or you can deploy somebody else's. And yesterday we talked about deploying somebody else's, and today we're going to talk about that first piece. We're going to be talking about actually creating our own. And the roadmap for this talk is, as I mentioned before, we're going to talk about what machine learning is and what it isn't. And deep learning falls into that. Deep learning is a subset of machine learning. There was a great tweet a couple of days ago that you call it AI when you're trying to sell a tool, and then when you're actually trying to hire people, you call it machine learning, because those are the only people you can find. Then we're going to be talking about Jupyter Notebooks. We're going to be talking about Azure Notebooks, which is just an implementation of Jupyter Notebooks. Going through some recommended resources. Most of them are free, so that's always nice. And then answering any questions if you guys have them. So that first piece, what is machine learning? And I love seeing XKCD on a movie screen. This is awesome. Are you guys familiar with that comic, the XKCD? Yeah. So machine learning has a lot of hype around it right now, right? So and varying flavors of hype. Most of it kind of towards the negative end, right? So you always get it. You always get a response back. You always get an answer. But for the most part, it might not be the most confident thing in the world. That's part of the reason why people love deep learning so much, is that it'll pretty much always give you the right answer, because it doesn't matter if you're using a convolutional neural net or whatever, but it won't necessarily tell you why you're getting the correct answer. Machine learning is a little bit more nuanced. So if you want to get a response back for machine learning that actually makes sense, that holds up over time, that isn't drastically overfit, that's very much an art. And you're going to be dealing with very much smaller data sets and usually smaller numbers of features. So I love this quote, machine learning is the science of getting computers to act without being explicitly programmed, but instead letting them learn a few tricks on their own. So instead of actually writing out code, for loops or if statements or whatever, you're basically going to be telling the computer, hey, here's my data set. Look at these different characteristics of my data set and tell me which one is most important or which combination of these features is important to get this particular classifier. So to say, yes, this person will default on a loan, or no, they will not. So let's take a look at a presentation that I did a while back on machine learning itself. So there are a lot of texts, or there is a lot of text on these slides. Don't get excited. We're just going to be touching on them, and you'll have them as a resource afterwards if you want to review them. But machine learning is everywhere, right? And if you don't like it, well, tough. Like every aspect of your life is dictated by deep learning or machine learning. So if you go on Amazon's website and it recommends you products, that's something called market basket analysis. And what it means is that it's looked at a number of people who are very similar to you, whose buying patterns are very similar to yours. It's noticed what they have purchased, and it's recommending you similar things. If you go and you look at predicted weather patterns, that's inclusive of a deep learning model. If I want to go and find like a new dress, and whatever website I'm on is giving me recommendations that look similar to what I purchased elsewhere, that's also machine learning. Netflix recommendations, right? So recommending you movies that are similar to movies that you've liked in the past. All of these things. You're all kind of blatantly bombarded with deep learning models every single day. So there are a number of subsets of data exploration. So you have kind of the mundane, looking at static historical data. That's mostly descriptive statistics, descriptive modeling. Then you have kind of the predictive modeling, which is what we're touching on today, which is trying to use historical data from the past to understand what will happen in the future. And then you have things like cognitive computing. So giving you reasoning and learning capabilities, and that's kind of what cognitive services does that we saw yesterday. You have two subsets, so supervised versus unsupervised, and we also talked about that yesterday. So supervised is classification or regression. It means that your data sets have been tagged and that you're understanding what they should be classified as. Unsupervised learning is something that you have to do the work. So it's things like clustering or association. And then there's semi-supervised, which you've probably heard about in the context of Google, if you've heard about it at all. But it's understanding that most of the data is not going to be classified completely. So being able to make smart decisions about what it should be classified as with a confidence level, incorporating that back into your extremely large data sets. So semi-supervised learning usually only comes into play during deep learning implementations. So the process of building out a machine learning model, it's 5 steps. Lots of different companies have different acronyms for it, but it's mostly around data acquisition, understanding a business problem, cleaning up your data, building out a predictive model, training it, evaluating it, testing it, retesting it, so with the holdout validation set, and then building up an operational strategy. So being able to say, all right, well, we'll refresh this model every month, we'll refresh it every couple of weeks to make sure that the data drift isn't too bad. That's just some more additional vocabulary and some discussion about data pre-processing. And again, lots of text on these slides. We're not going to be talking about them the entire time. I do want to point out, though, that if you have any questions about specific machine learning models that you've heard about before, so decision trees is one that we looked at yesterday. Bayesian models, clustering, association rule learning, artificial neural networks. This deck, which is on my GitHub, will have an explanation for those. So deep learning, what deep learning is an implementation of neural networks. And it's new now, but neural networks have been around for decades. They're not new. So why is deep learning get all of this attention right now? And it has to do with the massive amounts of data that's being accumulated either by click rates, by sensors, by whatever. Suddenly we actually have the ability to take these higher dimensional problems and use them to their full extent. So the way I always like to phrase it, you would like to use, so if you're predicting the price of oranges next year, right? Like if that's your thing, or how many widgets your company is going to sell in June of 2018. That is not something that you would probably want to use deep learning for. That's like, that's on the lower dimensional side. But if you have hundreds or thousands of features in your sample space, if you have these massively dimensional problems, that's when you would want to use deep learning. Massive amounts of data, lots and lots of features, and not really a firm either physical understanding of the problem or an expert understanding of the problem. So neural networks then, machine learning for pretty much everything else. Excellent. So how would you choose? Right, so we've got all of these great resources available. How would you choose a machine learning algorithm? If you can go and copy paste code from Stack Overflow to solve whatever problem that you've got in your business, what are the tools that you would have to make that step? So this is an app that Microsoft has developed. I'm not sure how well we've marketed it, but what it does is it goes through and it answers your question, right? So can you guys see this? The different questions? Yeah, excellent. So say, so if you want to predict values, that would probably be a regression. If you want to predict between several categories, that sounds very classification-like. Discovering structure, that sounds like a clustering problem. But as you click on these things, right? So if I click there, it tells you some of the options that you would have, right? So is this tweet positive? Is it negative? Will the customer renew their service? Which of these two coupons draws more customers? And then if you click explore this module, it gives you the sort of family of algorithms that this falls into. So two-class classification, also called binary classification, and gives you examples to documentation, and then also examples of how that was implemented with code samples. So it takes you specifically to the Cortana Intelligence Gallery to give you that sample. So this, for example, would be credit risk prediction, right? And then it would walk through the problem, give you the code sample, and then let you kind of open it up and deploy it yourself and give you the option to deploy it as a REST API. So that's kind of nifty, right? If you come to this app with a question, it gives you an answer. It points you in the right direction towards one. If you'd like to have kind of a visual introduction to machine learning, this is a great website that was recently put out that goes through decision trees. So if you had to determine whether a home is, if you were going to purchase a home in San Francisco or New York, what would be the different features that you would want to consider? So you would probably want to start with clustering, and then build in a machine learning model based on those clusters that you've distinguished. So this is another great resource for following through with the decision tree model. And you would actually get to see the probabilities as you would move through that model and how they would divide up based on those feature analyses. So that's nifty. And that's machine learning. And There are a ton of resources available for you to use. And again, 5-step process, right? You start with the data set and a question. Getting the data cleaned and getting the questions solidified is always the hardest part. Picking the model, not so awful hard. It's usually about 5 lines of code if you're working in R, or about 5 lines of code if you're working with scikit-learn and Python. It's not that difficult. Hyperparameter tuning might take a little bit. So that's basically changing some of the parameters that you're feeding into that model. But other than that, not so much. So let's talk now, provided nobody has any questions, about Jupyter Notebooks. So raise your hand. Who's heard of Jupyter Notebooks before? Excellent. So not a whole bunch of people. I'm disappointed. Everybody, that's your homework for tonight. Go home and learn about this. But that's a very lovely ringtone. So I was nervous about the internet connection today and decided to spin up the notebook server on my personal laptop. So you'll see its local host right here as opposed to like actually using notebooks.azure.com. But we'll take a look at it later and like fingers crossed the internet will be stable. But yeah, so let's take a look at a Jupyter notebook. And what this is, and this is available on my GitHub if anybody wants to take a look. It's an interactive, immediately accessible development environment that if you want to include code or change code and modify it on the fly, you're able to with no problems whatsoever. So this is an implementation of several machine learning algorithms on a singular data set. So this would be input data that's classified in kind of like a concentric half circle thing, so it looks kind of like a peace sign. This has blue values in the center with red outside it, so you could think of this as like a mountain, so elevation if you're looking at it from above, and then a couple of others, and how effective those different algorithms are at classifying based on those data structures. So understanding your data is massively important on the accuracy of your qualifying algorithm. Like linear SVMs, they fall apart whenever you have this mountain-like structure, right? So a Jupyter Notebook, if I double-click here, it exposes the markdown, right? As I hit Shift-Enter, it reevaluates any code that I have within the cell and makes it so that you can interact with it on the fly. You also have the ability, as you move down, to be able to take that Jupyter Notebook and expose it as a slideshow. And I touched on this before, but if I do that little number, it launches a slideshow presentation for the notebook that you just created, right? So each cell is exposed as a slide, and if your boss has any questions about the text that you have there, they would be able to ask you to change a particular parameter and see it changed in real time. So Jupyter Notebooks are pretty cool. They're very sort of big in the machine learning and the Python and R communities, and they've started getting even more traction in industry. So if you look at the supporting companies for this, you see Google, you see Microsoft, O'Reilly, Northwestern, NASA. Pretty much everybody who's in the scientific computing world is using Jupyter Notebooks to visualize their models. And all of this code, you can either expose it as a .py file if you're a Python developer, a .r file if you're an R developer, and there's even an option for F#, for Ruby, for all of you C# fans. So just to get kind of a feel for the room again, how many people, what languages are you using? Is it mostly JavaScript or, so JavaScript, hand raise. .NET, hand raise. Whoa, wow, excellent. So yes, so you guys get to have all of your NuGet packages in the F#, implementation. But yeah. So Jupyter Notebooks. And what Microsoft has done, so developer hat, putting it on. What would be potential problems of implementing a Jupyter notebook locally and wanting to share it with your friend, right? Or at least like if you have cooler friends than me. Like nobody ever wants to see what I code. You know, if I post it on Facebook, nobody cares. But so say you built out this great visualization at work, and you want to share it with somebody else, your colleague down the hall. What would be a potential problem? So there's always dependencies, right? Like so say I have this model built out, and it looks like I'm importing a whole bunch of libraries, right? So I'm importing NumPy, Matplotlib, scikit-learn. Down here I'm importing Seaborn to do some visualizations, and they're all specific versions of those things. So if I wanted to share this with somebody else, some colleague down the hall, I would need to have, you know, like a dependencies.txt file with all of the packages that I use in their version numbers, and the person would have to go through and they would have to download it, and it would be very frustrating whenever they came back to your office and said, Paige, why didn't this work? You know, like it's talking about Seaborn, and Seaborn doesn't make any sense. So that would be kind of a nightmare. You could also have an issue where maybe you wanted to have kind of a dynamic coding environment, right? Like you wanted to be able to have like a code pair with your colleague down the hall, but instead you're stuck kind of sharing this singular file and kind of working through .ipynb files. And people already do that now with Excel, right? It's like you save the Excel document as an XLSX, you send it to somebody else, they save it again, they send it back to you, and it's very frustrating, and you always end up with this like this long string of history that this file has gone through, and it's awful. So a way that we have around that is notebooks.azure.com. And this is a free implementation, so as long as you don't use more than like, I want to say 4 gigabytes of data, you can use it as much as you want, but it's Jupyter Notebooks implemented in a way that you can share them via URL. So instead of having to spin up your own notebook server on your personal laptop, or like, you know, find a server somewhere or spin it up on a cloud somewhere so that some dude down the hall can see your notebook, you can just put it here and send them the URL, and they can interact with it there. They can you know, fork it and save it and make modifications, and then you can use it through GitHub. Either way, like it makes it so that it's a more interactive, more dynamic coding environment. So if I sign in, you'll see the most recent libraries that I've interacted with. So the Kevin Bacon age detection, the Quicken Loans Tech Conference, those guys. You can go through and you can take a look. You can take a look at the notebook server as it's implemented. So what it's doing right now is it understands that this notebook is written in Python. It understands that I need to have it interactive, and it goes through and it allows me to look at that notebook itself. So that's cool, and it's a great resource for people to use. The other thing that I want to make sure to point out is that notebooks.azure.com comes plagued with a lot of interactive libraries for you to use. So for example, this CNTK one goes through, and if you ever have wanted to learn about deep learning, learn how to use the MNIST dataset, which is kind of handwriting analysis. So the thing that we saw yesterday where there's automatic text recognition, you could find out how that's actually implemented. So this is a logistic regression, but there is a .ipynb file a little bit afterward that is MNIST. There we go. So there are like 20 data sets that everybody uses for deep learning and machine learning, and you get really tired of them after a while. So one is the iris data set. One is this handwriting thing with like, it looks like a kindergartner kind of scrawled on the board, these things. But what there's another one for conversation analysis that actually is kind of fun. So I take it back. It's first dates. So like they have this collection of first dates that are all blind dates, and you get to hear the conversations that the people are happening as they're happening, and that's what you use for conversational analysis. But yeah, so the thing that I showed you yesterday that does automatic handwriting recognition, here's how it was implemented. This is the code that was used to generate that with CNTK. So you can see it as it goes through the model, as it's creating it, what it's deciding on for each of the layers, and you can see the training as you go along and the error rates for each. So we have that for CNTK. We have it for a number of other options. So we go back to libraries. Into Azure Notebooks. We have an introduction to Python, an introduction to R, and really, if you're serious about deep learning or machine learning, either one, you would probably want to start with these two. An introduction to F#, so functional programming on the .NET side, sentiment analysis for tweets, creating and deploying an intelligent cloud service, predictive maintenance and manufacturing, all of them extensive, like usually about 12 files worth of documentation for you to get started with either one. We also have Jake Vanderplas's Python Data Science Handbook. So you've probably recognized this from O'Reilly, but we got it for free. So if you don't want to have to pay, you can go through and run all of the iPython files that show you how to actually use machine learning. So I don't think it gets started until around like chapter 5. So it starts with data analysis, so some tools for that, things like pandas, if you've heard of pandas, some data visualization, so using Seaborn or Matplotlib, and then actually getting into the to the real meat of it, which are those different machine learning models. So there you go. And this is the iris data set that I was talking about before. So going through and creating a feature matrix, understanding the API, creating it in kind of a linear model, so just using a naive Bayes classification, and then going through the MNIST data set again. So what I want you to understand is that for each problem that you have, there are a number of models that would potentially be useful for you to use. And the way that you use it, so the creativity that you have in terms of feature selection, or in terms of like which algorithm and how you tune it, it gives you a little bit more of an edge in how predictive your model would actually be. So a question, I guess, for everybody in the audience, what would you be most interested in taking a look at now? Would you want to see more on Azure Notebooks, or would you want to like actually walk through a machine learning model and how you would go about architecting it? And second one, excellent. That's the one that I was navigating to. So cool. So this is the one that we looked at yesterday and just kind of touched on. I'm glad I get to talk about it more. And it's using risky, it's determining whether or not a person will default on a loan from a bank, right? Based on a number of characteristics that you have about this person. So some things that you know about each of these people that you have. So think about it this way, right? Massive data set, all of the bank's customers, and about each of these customers, you know their checking balance, so how much money they've got in their bank account, the months of the loan duration, so how long they're asking for the loan. So it might be 6 months, it might be 36, so like a typical 3-year loan. Their credit history, which is everywhere from like, oh my God, they're about to default on their house, to they have an American Express Platinum card, and that's awesome. What? Oh, gotcha. So that is a great question, and I probably should have clarified. It's basically like, so say I come up to you, and I'm like, hey man, I want $2,000. I promise I'll pay you back. Like, absolutely. And you say, okay, Paige, I think you're a trustworthy person. You look like you would pay me back. And then, a week later, you're yet to be paid back, and I say, sorry man, I've gone bankrupt. Can't do it. So basically, defaulting on a loan is that suddenly this person who has taken out the loan is no longer able to pay. And they're legally not required to pay anymore. So the bank is out $2,000, and the person's just like, whoops, I'm bankrupt. So student loans in the United States are an example of something that you can't default on, even if you do go bankrupt. So no matter what, if you're taking out $20,000 to get an education, you're going to have to pay it back, even if you're a bag lady on the streets. So that's like something that a bank is real excited to get, is because they're sure that they'll get it paid back. Medical loans, not quite so much. But does that answer your question? Yep, you got it. And so the purpose is another field, right? So whether or not they're taking out money to pay for a car, whether or not they're taking it for their business or for a house, something of that nature. So whether or not the bank would be able to take back collateral from the person. Their employment duration, so whether or not they've had a job and for how long. The percentage of income that the loan would be required, the years of their residence, their age, their other credit history, their housing, their job, how many dependents they have, their phone, lots and lots of data about these people. In reality, it seems like, a lot of information about the person. Banks love this kind of data, and they've got hundreds, if not thousands, of variables about people. So like if you have that kind of data, then you're probably going to be using something like a deep learning model. This is small enough so that a machine learning model would be able to sink its teeth into. So 1,000 observations, that's not a ton. Just think about observations as like rows in an Excel spreadsheet. Features, think about them as like columns in an Excel spreadsheet. So 1,000 rows, 17 columns. So we understand the data. We've got a data set. Now let's explore it, right? So DM stands for Deutsche Mark. So this is telling you about the checking balance in these people accounts, right? So if it's less than 0 Deutsche Marks, that means that they've been a little bit too greedy and they've been purchasing more things than they could pay for. If it's unknown or greater than 200 Deutsche Marks, that's probably someone that you would feel a little bit more comfortable about giving a loan to. There's savings balance. You see it there, so kind of a similar situation, less than 100, greater than 1,000, 100 to 500. And you can start getting an idea for which people are responsible with money and which people are kind of not, right? So the month's loan duration, those are kind of the distributions there. The credit amount that they're asking for. And then this is the crux, right? So this is the determinant of what our machine model is going to be looking for. And it tells us that 700 out of that 1,000 paid back their loans. So they did what they were supposed to. 300 did not. And what we want to try to figure out is which of those 17 variables, which combination of those 17 variables indicated or could indicate that those 300 people weren't going to pay you back. All right, so we got that. So now we're going to go about and randomly select. So right now, the values aren't sorted in any sort of randomized order, right? So it's just the 700 good ones who did what they were supposed to, and then the 300 bad ones that, you know, went bankrupt and, you know, went off to their island location in the Bahamas or whatever, with the money that they were lent to by you. So what we need to do is we need to randomize the selection so that we'll get an even distribution whenever we select our training data set and our test and our holdout. So we randomize it. We create a new data set for that randomized list of people. And then we check to make sure that our random data set looks different than the data set that we had initially. So we divide up 90% for training. This is a little bit high. I selected 90% mostly to determine whether or not that would have an impact on the accuracy of the model. Usually the typical split is like 70% for training, 15% for testing. So once you've trained, you test it with 15% and see how well that performed. And then you aggregate that up again. So you would have 85% for training and then 15% for that holdout. So it's basically just going through and training each one. And what we have here is just a sort of sanity check for the distribution. So for the 90% that we extracted from that 1,000 that's been randomly sorted, I want to check to make sure that we still have about 70% who say no, you know, that they didn't default on their loan, and about 30% who did. So yes, our randomly selected 90% of the data looks very similar to the data set that we had initially. So now that we've got data that we want to train on, we go about training it. And this is how you train a model in R. That is one line of code, and that is correct. So if anybody, you know, had ideas that you would have to go through and have a whole bunch of code required to do a machine learning model, nope, it's one line. We're using C 5.0, and that's an industry standard for decision trees. So what you do is you remove the predictor column. And why would you want to do that? Because if you keep the predictor column in your model, that's the feature that it'll always sink its teeth into. It'll just be like, oh, well, okay, well, every time I see the word no, I know that a person didn't default on their loan. So we're just going to look for the no each time. And then I can give you 100% accuracy. But that doesn't really give us any information about the people. So that's why we would remove that column. And there is our training set. So we have 900 samples. That's the size that we selected. 16 predictors, which is the size of our feature set. And now we're getting a summary of the credit model. And that is the decision tree that was implemented. So you can see here, in terms of outcome, what this decision tree looks like is the typical decision tree that you would expect to see. So it's cycling through each one of those features, and it's saying something to the effect of, okay, if this person has greater than $200 or 200 Deutsche Marks in their checking balance and a pretty good credit history, and the month's loan duration is long enough, then yes, it looks like they will always be good on their loan, right? And this summary gives you, so we had 13.9% errors, which is pretty dang good. So that's saying that 86.1% of the time we were correctly classifying whether or not a person did or did not default on a loan. And that is with one line of code, pretty much. Can you tell why I like R? Scikit-learn is about the same way. Like if you take a look at the Scikit-learn website, which is phenomenal, by the way, like it is better than any textbook you will ever find about vanilla machine learning. People contribute to this like whoa. So if you want to go and look at machine learning or regression or generalized linear, whatever, like you have an entire textbook worth of information about each of those potential models. It's absurd. But yeah, so back to that risky bank loan, right? We build out our sort of, this is a matrix that tells you how many false positives and false negatives you have, right? So if we predicted a no for default, and it was actually a no, right? Then that's the ranking that we've got. And you want to maximize the no's that align with the no's and the yeses that align with the yeses. So training always works out better than the actual classification on the data that has not been seen. So we trained it up on that 90% of data, and then we test it on the remaining 10% to make sure that it was accurate. And then this goes through and it kind of attempts to boost the model performance. And how would you do that, right? So all you guys, I assume you're familiar with something called Monte Carlo methods, right? And it's basically just doing the same thing over and over and over and over again a whole bunch of times, and then just getting an idea for the distributions that you would have if you ran that same experiment over and over and over again. It's the same general idea, right? So you run the decision tree a number of times, and then you see kind of the overall impact, like what the distribution is. Random forest, if you've heard of random forest, and that's a go-to for most data scientists because it, again, usually gives you a pretty correct answer, but it also gives you more insight into the model than a deep learning or a neural network. It takes the most accurate predictors, right? So if it sees across all of these numerous iterations of a model that you've done that the most critical impactor was how much money a person has in their bank account, then it always includes that as like the first branch in the decision tree. And it sees that, you know, a number of the other features aren't quite as important. It selectively removes those. So if you scroll down, those are all the numerous trials of the decision tree. You can see each one. So there's trial 6. I think I ran it about 10 times. And it does give you slightly better performance, right? So you have a boost. It gives you a time response. And we did get it down to, I think it was like 3, yeah. So like a 3.4%. Was the incorrect estimations. So that's machine learning. It's very simplistic, right? And so a question that you could have would be like, what would designate that to be a deep learning project as opposed to a machine learning project? And that would be a question for your customer. So this is very easily auditable. If somebody comes up to me tomorrow and says like, oh, hey, Mr. Bank Guy, why did you decline my loan? You know, I think it's because of my race, or I think it's because of my gender. You could point back and say like, well, no, actually, it's because you're negative $25 in your bank account and you've never paid back a loan before. And our decision tree made that decision based on those criteria. But if you're building out a deep learning model, so say instead of 17 features and 1,000 records, you have, you know, a million records that you're looking at and like 100 to 1,000 features, and you've built out this lovely deep learning model that gives you excellent accuracy. If a person comes up and tries to sue you, you can't give them a direct answer. all you can say is, well, you know, the computer told me to. Computer said that you were going to be a loser and weren't going to pay back your loan. So that's the decision I made. But there's no real kind of audit trail. So the way that deep learning works, I don't think I touched on it quite a bit, but it's through something called backpropagation, which is similar to that random forest thing that I mentioned before, in that you have a number of nodes, and each node kind of looks at one specific aspect of the problem and makes a decision. And backpropagation, it's kind of like bullshit detection. So each one of those nodes will give you an answer. And as you keep iterating through those layers, you find out that some of those little nodes are giving you an incorrect answer a majority of the time. And so you listen to them less. So it's like if you have a friend that's always telling you like, oh yeah, man, you know, I totally went out and I lift like 500 pounds. It was awesome. You know, I'm just so pumped. I'm so strong. And you look at him and it's like, no. And so you stop paying attention to him when he starts telling you about his workout regimen. It's neural networks kind of the same way. You just stop listening to the nodes that are telling you incorrect information, and you preferentially listen to the ones that are giving you accurate information. And you just keep cycling back through until you get really, really high accuracy. Cool. So it's also, I feel like I should also mention, because I've been hating on deep learning kind of this entire talk, right? Like I've been saying machine learning is better. Use machine learning every time that you can. Don't just throw deep learning at everything. But it's done a lot of great stuff recently. So Andre Karpathy, who is this researcher at Stanford, he, bless his heart, he like went through and he personally, over the course of like a day and a half, classified pictures. So he said, that is a cheetah, that is a parrot, that is a squash, that is sunglasses, that is those sorts of things, for 36 hours. And he was like 6% inaccurate, something of that nature. So he was wrong that many times out of however many pictures he looked at. So he's like the human benchmark for how accurate a human can guess what a picture is. And deep learning, the convolutional neural nets, they've beaten him. So now in terms of image recognition, computers are better than people. In terms of Go, right? So playing the game Go, computers are better than people. In terms of translation, so having a translator be able to take one sentence in one language and give you the correct sort of intonation and understanding in another language, neural nets are better at that as well. Like apparently translators are wrong 8 or 9% of the time, and now computers are only wrong like 6% of the time. So lots and lots of advantages, but there are so many avenues where machine learning is good enough. And as you can see, it's relatively simple to implement. It's not a difficult task. So if you look back at this guy, right, this Python notebook file that we were taking a gander at before, you'll see a whole bunch of resources listed. So the GitHub repo and slide deck, of course, the URLs that we looked at, so the scikit-learn website, the Project Jupyter website, all that good stuff. And then down here, a whole bunch of textbooks and recommended learning experiences. So there's a deep learning specialization on Coursera now. It's 5 courses. It's taught by Andrew Ng. He's the guy that was awesome at the machine learning course. It's not that expensive, especially if you blast through them real quick, get a buddy. There's R for Data Science, which is an open source project by Hadley Wickham. The Python Data Science Handbook, that's the one that's also free for you to use. Python Machine Learning by Sebastian Raschke, it's fantastic. And then some additional textbooks. Peter Norvig works for Google right now. But yeah, so I would highly recommend taking a look at those guys. And then also taking a look at the code that was used to implement the visualizations in the notebook. Because again, 4 lines of code, and you can do some pretty impressive stuff. This is why I love Python and R. Like, it's just so nice, right? Shift enter. And Jupyter Notebooks, they're free. I'm not sure if I said free as many times as I should have, but they're completely free for you to download to do whatever you want with. And they're also included in a number of Azure offerings. So data science virtual machines come preloaded with them, deep learning virtual machines, and then also the Azure Machine Learning Workbench, which is what we were looking at before. And a number of libraries are associated with those as well. And I also, so what frustrated me so much about Azure and Azure Notebooks itself was that, so let me pull this up real quick. So there was no clear place to go to like take a look at what R and Python packages had already been downloaded. So I created a cron job to run every night to export the packages, their dependencies, the versions, those sorts of things for Azure Notebooks and for Azure itself. And as you can see, it's pretty extensive. So those are just the R ones. There's another one for Python. But if you just want to go to like a single one-stop URL, I have, so I think I tweeted it, and I also included it at the end of the iPython notebook. But yeah, definitely recommend exploring if you have any interest or any passion around machine learning or AI. Cool. So, any other questions? I think it's still, you have like millions of questions. Yeah.
So first, those Azure Notebook projects.
Yes.
You only get them public, or you get private?
You can also have private. So you can have private repos. You can also have repos that you share with just a specific number of other people. You can have repos that are completely public. And you can also download any packages that you would like. Another really interesting thing is that you can use sort of command line tool options as well as if you just preface it with a bang. So like if you have the exclamation point and then wget, you can pull in CSV files, right? So like any web URL. Let me see. I think I have an example in here. Let me check. Visualizing data. Yeah. So you can pull it in with curl, right? And then also wget. But if you just have like an exclamation point to preface it, you can pull in the CSV file, call it whatever you want. So I just called it bike data, and then visualize it however you need to within the context of this Azure Notebook. So you can pull in GIFs, you can pull in JPEGs, but yeah. You can also pull in entire GitHub repos. And people have gone crazy with Jupyter Notebooks, right? So this is a gallery of interesting Jupyter Notebooks. Interesting is obviously dependent on the person, but you can see there's pretty much a discipline for everybody. So there's social data, there's psychology, there's economics and finance, there's signal, sound, and image processing. People have like created academic papers built in Jupyter Notebooks to do reproducibility of code. Or reproducibility of experiments too. So say some guy at Stanford implements a particular experiment on lunar ultraviolet or whatever. You want to try it on your own data. You can just take his Jupyter Notebook, massage your data into the format that it needs to be in to run with his code, and then feed it in. And suddenly you've got a paper too, right? Like that either supports or detracts from his research. So again, linguistics and text mining, signal processing, general topics in scientific computing, social data. So it just keeps going on and on and on and on and on. And each of these guys, whenever you get to Azure Notebooks, you can just, there's an option for download data. So file, download data, and you can just clone any GitHub repo and it automatically saves in your environment as an interactive notebook with all the dependencies downloaded. So, yes?
I have a question about decision trees. So
Yes.
you pick a feature to split the branch, but how you pick the best, the best split? How you pick the
Yeah.
feature that makes the best split?
So you don't have to. That's kind of the beauty of it, right? Is you just tell the computer, all right, computer, like you pick what you think that feature should be based on the distribution of data that you see and based on the algorithm that's already been created. So as a programmer, you're kind of hands off. You're just like, computer, do your thing, and I'll come back in 30 minutes and see what you got. And that's why you would want to do the process of iterating over a number of those decision trees. So you can see the computer like try different avenues, see which one was the most effective, and then kind of take all of it up into a bundle and give you the best solution. Does that make sense?
Yeah.
So yeah, so machine learning, like it's if you're lazy, and man, I'm lazy. I am so lazy. It is the best job in the world because the computer's writing all of the hard code for you. The algorithms have already been implemented. You have to do some parameter tweaking, and you have to do a lot of some guesswork and sort of domain knowledge around feature engineering. Which is difficult. I don't want to detract from feature engineering, but for the most part, like the running of the model, the building of it, the computer is doing it for you. Yes?
For training a specific set and a specific methodology, what do you think is a good accuracy to achieve?
A good accuracy. So it depends. Well, so I would say that is a question for the person that you're building it from. Or building it for, right? So if your boss is happy with like 75 to 80% accuracy, I think you should be too. But in general, you try to get around 80 to 85% accuracy if you can. But that's a moonshot to kind of shoot for. There are some that you're never going to get that high of accuracy for, and that's just. It's just an aspect of maybe you don't have enough data, maybe you don't have enough features included in that data set, so either it's a problem with number of observations or number of features. Maybe there's some sort of nuance to the problem that you haven't appropriately sussed out. But for the most part, that was a very simplistic example, right? And it's also intuitive. It makes sense that if a person doesn't have a whole bunch of money and has already defaulted on a number of loans before, they're probably going to default on loans again. So, yes?
Why is this problem more appropriate for decision trees instead of, let's say, logical regression?
The what now?
Logical regression.
Oh, logistic regression. So I would say that this would be a good problem for a decision tree because of that auditability that you would want to preserve, right? So it's, and also because you would have a loan grantor carrying out this problem, and it's always nicer to give him like a list of rules. So hey, here are the top 5 things. If a person meets these criteria, don't give them a loan. Right? So there's a human aspect to this problem that works very, very well with decision trees. You could, so a regression task 2, right, is it's probably going to give you, if you do a regression, it would give you a number, and we're not really looking for a number, we're doing a classification problem. Logistic regression, I believe it would do a classification for you though. So, but the real crux of it is that there's a human component to this system. Like some poor guy in an office is going to have to be saying yes or no to these people, and you want to be able to give him like a very clear decision model for that. Excellent. Yes. Uh-huh.
In which cases would you prefer to use name-based over decision trees or random forests?
Right. So it would again be dependent on your problem. And you would probably want to try out multiple algorithms instead of just picking one and running with it, right? So that's like if you look at the Cortana intelligence gallery that we were displaying before. So the questions that you would have here, it never really gives you like a definitive answer for the algorithm that you should implement. It gives you like a family of algorithm choices that you should explore and see which one best fits your problem. Cool. Excellent. So I am going to let you guys go. I believe we're at time. But this has been fun. If you have any questions about machine learning or AI, feel free to ping me on Twitter or to send me an email. I'm paige.bailey@microsoft.com. If this excites you, and it should, always delighted to talk about it. Cool.